Hello. This time we're going to calculate the inverse of a 2 by 2 matrix, but we're going to do it in a slightly different fashion from the traditional row reduction process. Yes, we're going to incorporate that, but we'll also take into account the structure of the matrix itself. So, to begin with, well, these are trigonometric entries, right? Here I have an exponent, right? And here I have a trigonometric function. So what I'm going to do is, as is in the standard procedure, I'm going to copy the entries, right, and make an augmented matrix. So I have et sine t, e2t cosine t, 2e to the power of t cosine t, negative 2e to t sine t. And then on the other side, I'm going to introduce the identity. So I have 1, 0, 0, 1. And hoping for the best in the reduction process, at the moment that we are done with the row reduction, what we're going to see is that on the right side of this augmented matrix, we will have the inverse, while on the left side, we'll have the identity. So let's start. Right? Couple of things to notice here. First is that if I multiply the first row by 2 sine of t, and if I multiply the second row by cosine of t, I get something that looks like this. Two et sine square of t to e to the 2t cosine of t sine of t, and then 2 sine of t, 0. Now for the second row, I get 2et cosine square of t, negative 2e to the 2t cosine of t sine of t, 0 cosine of t. Well, okay, two operations just described here. Now, the next thing that I'm going to do is to row 1, I'm going to add row 2. That was the whole intention of performing these actions, because I want to utilize the fact that the sum of sine square and cosine square is equal to 1. So what I get is the following. On the entry 1, on the entry at column 1 and row 1, 2et. Of course, part of that is that these two cancel, right? When I add them, so I get 0 for that one. Now, what happens as we continue on the augmented side? Well, for that, we still have 2 sine of t for that, and we have cosine of t. Now, the second row remains intact, so I leave it that way. So I have 2et cosine square of t, negative 2e to the 2t cosine of t sine of t. This one is 0, that remains as 0, and this one is just cosine of t. Okay, now, next operation. I notice that this entry is just a factor away from this entry. How much? Well, by cosine square. So that's what I'm going to use. So for my next row reduction operation, I have to row 2, I subtract cosine square of t of row 1. Now what happens when we perform that? Well, we get 2et. That remains intact on the first row. 0. Then followed by 2 sine of t, cosine of t, 0 on this entry. This one remains intact because I have a 0 here. So I have negative 2e 2t cosine of t sine of t. But now what I get is that I'm multiplying the first row by cosine square. So I get 2 cosine square of t sine of t negative. Right? I'm subtracting that. Now I'm multiplying this by cosine square. That becomes a cosine cube. So I have cosine of t minus cosine cubed of t. Now, I want to identify a few things here. Why? Because as a side computation, when I have cosine of t minus cosine cubed of t, this is also factorable in this way. Cosine of t times 1 minus cosine square of t. But this one is known. Right? This one is just sine squared. So this is just cosine of t sine square of t. Okay, just to keep it handy. Because the next thing that I'm going to do is the following. What I now want to perform is a reduction on the first row. But now here, it's possible, because this entry is non-zero, it's an exponential. So I'll just multiply by the reciprocal of that expression. That would be 1/2 row number 1. Oh well, not just 1/2, sorry, but 1/2 e to the negative t of row 1. Now, what is the resulting operation of that? Well, let's take a look. On the first row, I get a 1. First row, first column. First row, second column, I still have 0. Now, for the augmented part, I'm multiplying this by this much. So I have e to the negative t sine of t. Now I'm multiplying this by this much, and I have 1/2 of e to the negative t cosine of t. Now, something that we would like to do immediately is to think of this as being non-zero, just to perform the reduction. Now, again, I'm not being that cautious, but we can do it, and maybe we can take care of those places where that entry is 0. Maybe there are not many, and we can fix them later. So, what I'm going to do is think and assume that this entry has a reciprocal. And the reciprocal, of course, should look like this. Negative 1/2 e to the negative 2t 1 over cosine of t times sine of t on the second row. That way, this one still is a 0. And now, under the assumptions that we are making, this turns into a 1. Just be careful. We are making an assumption here. But now what happens when we perform the multiplication? Well, let's not forget what we're doing. we're multiplying this against that. So 2, negative 2 times negative 1/2, that's just 1. Here we have a cosine square and a sine. On the numerator, here we have a cosine and a sine on the denominator. So what is that survives? Well, what survives out of this product is simply e to the negative 2t cosine of t. Now, lastly, we multiply this by this much, but let's not forget it is equal to this. So, out of this computation, what we get is the following. Negative 1/2 e to the negative 2t times, well, I have a cosine t sine squared. Cosine, sine. So what survives is sine out of this reduction. Now, let's make a simple verification. Just, it doesn't hurt, because we had made several assumptions, right? As we process it, and with the assumption that this is non-zero, it's something, right? There are several values of t for which this is 0. So why don't we make a verification? So now I'm going to multiply et sine t e to t cosine t 2et cosine t negative 2e to t sine t times e to the negative t sine t e to the negative 2t cosine t 1/2 e to the negative t cosine t negative 1/2 e to the negative 2t times sine of t. Well, let's see what happens, right? Row times column. So row times column. Okay. When I multiply this against that, that becomes e to the t times sine times e to the negative t times sine squared. Okay? So this against that. Now, when I multiply this against this, it is e to the 2t times e to the negative 2t cosine t times cosine t. What survives is cosine squared. Okay, so I have my entry at the column 1, row 1. It's cosine squared plus sine squared. But cosine squared and sine squared, 1. Okay, now this row against this column. Okay, this times that becomes 1. This times that sine t cosine t. Well, good. This one against this one. Okay. Now let's consider this portion. This against that. Well, when we multiply this against this, it becomes 1. But let's not forget, we had a 1/2 from this first computation, this product against this. Well, now we had it negated, this against this. And this one is a cosine, and this one is a sine. Well, we have it in either order, so now they just cancel each other, so this is 0. Okay. Now, this row against this column, it would be this against that. Okay, so I multiply this and this, it becomes 1. I multiply this against that, I have cosine t sine t. Of course, I have it twice because I have it here, because of this factor that I have. Well, let's not forget this against that. So now this against this one. So I have negative 2. This and this, they cancel, it becomes 1. This and this, sine, cosine. Well, but I had already a sine, cosine on the other side, and I had it twice. So now I had twice negative, also it goes away. So that is also 0. Okay, lastly, if I want to verify this against that, well, this 2 gets killed with this 1/2. This one is killed with this one and this combine into cosine squared. This one and this one get killed into 1. This one and this become 1. This one and this one become sine squared. So what remains is cosine squared plus sine squared. Well, that is just 1. Okay, so indeed, the assumption that we made still lead us to the correct answer. Now, what happened is that the continuity of these functions that we're using, well, help us in the process. So, I'm glad that we used them. See you next time.